All right, let's practice graphing some of these secant and cosecant functions. Now, it's always easiest for me to first start with the graph of the reciprocal function. Let's translate our secant or cosecant into sine or cosine first. Let's sketch a light graph of that function, sine or cosine, and then we'll start to consider the reciprocals of those key points, right? So anywhere the reciprocal function equals 0 will now really be a vertical asymptote. And the reciprocal of 1 is 1, so those points remain, but everything else will be flipped but bounded by those asymptotes, right? Let's try a couple. If you look at example number 4, it says to graph y equals 2 secant of 1/2 x. Again, the first thing I'm going to do is consider the reciprocal function. So the reciprocal of secant would be cosine, and I'm going to think about this equation as the reciprocal, y equals 2 cosine of 1/2 x. So I can then pick out the amplitude. I know that the amplitude of this function would be 2, and I know that the period would be 2 pi divided by 1/2, or I can think of it as 2 pi times the reciprocal, right? 2 over 1. So it looks like really the period on this one is going to be 4 pi. So I need to have a full cycle in a 4 pi period, right? So by the time I get from 0 to 4 pi, I need to make that full cycle. Now, if you look at the graph that they give me, they go from negative 2 pi to positive 2 pi. So I can't go from 0 to 4 pi. So I'm going to extend it from negative 2 pi to positive 2 pi, which is really the equivalent of my 4 pi. So I'm going to use this whole entire graph to reach one period, one cycle of my cosine or secant graph, okay? All right, so let's lightly sketch our cosine graph. Normally our cosine would start at 1, but this time our amplitude is 2, so I'm going to start at 2. Remember, I'm going to go all the way here to make half of my cycle or my period. So then here would be the other half, right? And then I need to go from negative pi to 2 pi. So from negative 2 pi all the way to positive 2 pi, my 4 pi is where I'm going to have my whole period, my whole cycle go through. So if I start at 2, I normally would go down to 0, and then I normally would go down to negative 2. If I work backwards, I'm going to go to 0, and then I'm going to go down to negative 2. So if I'm thinking about this, my light sketch of my cosine graph, it would look something like that, right? But now I need to consider all the reciprocals. So wherever my cosine graph equals 0, so pi and negative pi, the reciprocal of 0 is really going to be undefined. What that means now in my graph is that at those places, I'm going to have vertical asymptotes, okay? So then I'm going to continue graphing my secant graph, the reciprocal of 2. We're still going to stay there, but this time it's going to be flipped and bounded by these asymptotes, right? So here I'm going to be flipped but bounded by the asymptote. Here is my other point at negative 2 pi, and I'm going to be bounded by these asymptotes. So this would be a full cycle of a secant graph with the equation y equals 2 secant 1/2 x. All right, let's look at the cosecant graph, okay? Let's consider, oh my gosh, sorry, those are my dogs. Let's consider the reciprocal of my cosecant graph. Let's convert this equation into a sine. So 1/2 sine of 2x. Let's pick out the amplitude. It looks like the amplitude is 1/2. Let's pick out the period. The period would be 2 pi divided by 2. So 2 pi divided by 2 would really be pi. So by the time I get from 0 to pi this time, I have a full period. So on my graph, here's pi, here's half. I need 4 points total. By the time I get from 0 to pi, I should have a full period or cycle graphed, right? And the amplitude is 1/2. Remember, this is a sine graph, so where does sine normally start? Normally doesn't sine start at 0. It goes up normally to 1, but this time the amplitude is just a 1/2. So I'm going to go to 1/2, then I'm going to go back to 0, then I'm going to go to negative 1/2, and then I'm going to go back up to 0. Now, if the question asked me to graph the whole from negative 2 pi to 2 pi, instead of just graphing one period, I'm going to graph the whole entire thing. So I'm going to keep that cycle going and repeat that cycle over and over and over again, just so that I can cover the whole entire graph. If the question just asks me to graph one full cycle, then I could have just stopped from 0 to pi. Okay? All right, but we are not necessarily graphing sine, we're graphing cosecant, right? The reciprocal of sine. So again, anywhere my sine graph hits 0, I'm going to have vertical asymptotes. So I have lots of vertical asymptotes along this cosecant function. Anywhere my sine equaled 0. All right, look at all those asymptotes. All right, that means that anywhere in between where I have these points at 1/2, I am going to be flipped but bounded by these asymptotes. So it looks like our cosecant graph, if I were to continue it all the way from negative 2 pi to positive 2 pi, would look something like this. All right, so again, it is always easiest for me to graph the reciprocal function, kind of sketch it lightly with a dashed line, and then from there, plot some of those important points where it equals 0 would be vertical asymptotes, and then the other values would be flipped but bounded by those asymptotes. What I also think is kind of interesting, I know my graphs are kind of rough sketches, not the most beautiful pictures. So I always think it's interesting to graph these in a graphing calculator or Desmos so that I can kind of compare my sine graph to my cosecant graph just to kind of see how accurate I was. So try that out. Make sure you practice graphing not only your sine and cosine, but the reciprocal functions as well.